This video will discuss about antibiotic resistance. The new antibiotics are required because of so many reasons. For example, tuberculosis, as we know, it's widely distributed in the soil and it's very easy to be contaminated in the wood. If we get some hurt and touch the soil, it's much easier to get, very easier to get this tuberculosis, and very difficult to treat because it will form a core, very thick outer layer, and in a rest state, which means it didn't replicate itself and have a almost completely rest in a rest state and very difficult to treat it with drugs. Only limited and the macrophages also has difficulties to digest the outer layer of the TB. Another one is neocesarum or meningoidin, which also I don't meningitis. Wow. Also, this is a gram-negative bacteria, which is rich in will invade in the brain and spinal cord fluid. Also difficult to treat with drugs. That means this drug needs long-term of antibiotic treatment to fully eliminate them through the body, which means it need long-term of antibiotic treatment. Or another disease called AIDS is also on the AIDS patient and transplanted patient and even cancer patients. Why AIDS patient requires long-term antibody? Actually, it is in the late stage of AIDS patients. They are completely have no T cell in the lymph nodes, so they don't have ability to against with the bacteria, flus, so they requires and continue antibiotic. They continue to take antibiotics. If they are lucky, they don't get TP or other very difficult be treated pathogens. They will survive for a long time, but if they not lucky, they will die very soon. And the transplant patients, they have take some drug to inhibit the T cell formation. So this patient also much easier to get. I have less resistant to the bacterial pathogens and requires long-term antibiotic take up. And the cancer patients, in the primary stage of the cancer patient, sometimes they take antibiotic because antibiotic has some will disrupt the primary stage of cancer cell formation because they may bind to the chromosome to inhibit transcription process or inhibit the DNA replication process. This is a normal cancer cells to inhibit the growth. In the late stage, the cancer patient needs to get radiation or especially some radiation or other method treatment because of the radiation and some toxic chemical treatment will kill a lot of normal cell. The past experience shows If we take antibiotic, it will heal the patients, heal the chemical and radiation will hurt the patient, and the antibiotic will help the increase the healing process. That means we'll have less time for healing and have will quickly get next round of radiation treatment. Have large possibility to survive. So continue antibiotics take in with cancer patient is very normal because of the large demand. No, the abundant usage of the antibiotic and cause that fact cause the uh, human being the bacteria get some mutation that anti that resist to these antibiotics have the some mechanism like antibiotic efflux bomb is a bomb that continue bomb out of the penicillin or other antibiotics out of the cell. Um, so with this mechanism, we need to require more higher dose of antibiotic to treat this kind of mutated strand of bacteria. Uh, Another mechanism is antibiotic inactivation, which is an enzyme that degrades the antibiotic. And another one is alter the target site modification, will alter the antibiotic to more function. The last one is antibiotic resistant gene. Oh, sorry, I didn't read it very carefully. There's no other. Antibiotic resistant gene transfer means mutation caused by recombination through the bacteria by the mechanism like conjugation, transduction, and transformation. These three mechanisms are limited in species. That means some species has this mechanism, they're able to get the resistant gene from this mechanism, but some other strands do not able to receive this gene because the lack of they're not in this species, do not have the mechanism. Uh, Another fact is healthcare in healthcare, like hospital, because of the patients are crowded, so it's pathogen easier to transfer to through the patient. When this patient is healed, and the the pathogen will transfer to other patient, and the other patient will be affected and get disease. So they repeatedly being treated with antibiotics. So that will increase the resistant gene being transferred and become a dominant strand and continue increase the abundant usage of the antibiotic. Another one is in the farm for commercial business production of the meats. They usually abundantly use antibiotic to uh, help the pigs or chickens to survive in a crowded environment to reduce the cost. Another one is okay. Uh, then we will discuss about the test method. The test method to detect the antimicrobial resistance is divided into the culture-dependent and culture-independent method. The culture method include tube dilution, disc diffusion, and E-test that we discussed before. And the culture-independent method is isolate the resistance by PCR. The PCR with a carefully designed primer to amplify the resistant gene. If the resistance be amplified, that means resistant this in this strand there is some resistance exists, and qPCR also used to identify the amount of the resistant gene. Okay, that's all.